So word problems can certainly feel a little bit overwhelming. They can feel like kind of difficult questions, but we're going to break them down into like smaller steps, and very similar to what we were just talking about with equations that have fractions. They can feel difficult at first, but if you understand how to do that step by step, they become a little bit more straightforward. So here's a few bullet points of things to think about. We're going to define, in fact, this blurb at the top, getting the right answer is not really what our focus is, believe it or not. A lot of people think in math class it's all about getting the right answer, but it's also about what we're really focusing on is our form, how we're presenting our solution, writing out the steps properly. Why is that so important? Well, because in other courses, the questions get a lot harder. Some of these questions you might just be able to answer off the top of your head. That's not the most important thing. The most important thing is getting used to how we set up our solution in a formal way for communication purposes, as we've talked about before, but then also when the questions get harder, you can't just do it in your head. And we've kind of seen that already in this unit, but it's the same thing. You might not see it until maybe a little bit later in this course, but maybe not until a different math course where the questions are even that much harder. And this is the same kind of expectation that you're always going to have. So we're going to define our variables with let statements. If there's a diagram to draw, it's a really good idea to draw it and label it fully. Not only is it often required for your teacher, but it's also actually going to be helpful to you. Then we're going to set up equations. And then once we're done that's the whole setup part. Then we're just going to solve the equations, right? Equation or equations. For us, it's really only going to be one. And then after we've solved the equation, we're going to interpret our answer. And that's a therefore sentence or statement. Okay? So let's take a look at the first example. Two numbers have a sum of 33. We're going to come back to that. One number is 5 more than the other. Find the two numbers. Start with your let statements. Let what?
Let x represent 33.
Not 33, just a number. Because we don't know what the number is yet. So we're going to just say, but very good, let x, or whatever variable you choose, a, n, those are common ones. Let x represent a number, or the number. So one number is 5 more than the other. So if one number is x, what's the other number? We could do that, but we're going to keep it simple for this one. No. We don't know what the numbers are yet, but we know that one is 5 more than the other. So x plus 5 is the other number. Think about it. We don't know what the two numbers are. Could you just figure out what two numbers add to 33 where one is 5 more than the other? Yeah. Like you could figure that out. What would you start at? I don't know. Around 13, 14, 15, and just kind of start adding them together and figure it out, right? You could do that. But what is the system for kind of writing it out in some kind of way that somebody else can follow, so some kind of nice solution, but then also if the questions, the numbers are not as friendly, how we can set it up to actually calculate and solve it, right? That's what we're working towards. So we have two numbers. One is x, the other one is 5 more, so x plus 5. Again, we talked about this last week. If one of them is 5, 5 more than that would be 10. So 5 plus 5 is 10. If one of them is 8, the other one would be 13. 8 plus 13, 8 plus 5 is 13. Right? You add 5 to get a number that is 5 more than the first number. That's the part that we've been working on already, defining let statements, thinking about an expression of a number that's 5 more than another number, so x plus 5. Here's the trickier part, I think. The two numbers have a sum of 33. What are the two numbers? And what does sum mean? Huh? Go ahead. I think what you were saying was x and x plus 5. Good. And what does sum mean? Yeah, the total. So you're adding them. So we have one number plus a second number is 33. But again, what are the two numbers? X and x plus 5. Because that's how we define them. We said the numbers were x and x plus 5. So one number is 5 more than the other. Again, we don't know yet what the numbers actually are. Right? We don't actually know what x is. It's unknown. That's the whole point of a variable or an unknown. Okay? But I have the sum of two numbers, x and a number that's 5 more than x. The sum is 33. And now we forget about the fact that this is a word problem and we just solve it. I'm going to do a small extra step. There's no real reason to rewrite it that way, but for the lesson, I think maybe it helps. So now this is just an equation that we're going to solve. What's x plus x? That's x times x. 2x. So I got 1x and I have another x, so I have 2 x's. Okay, plus 5 is 33. And now what do I do? And again, we talked about this in the last couple of lessons where it's funny how when it's a harder question, we overthink things and we confuse things. But now I can just kind of zoom in on this line and say to myself, what do I do? I subtract 5 from both sides. Like this is one of those easy questions from the very beginning of the unit. I say easy because I think most people were pretty comfortable with it, right? Like you were okay with solving these. For whatever reason, when it comes from a word problem or a question with fractions or something, we think it's different. But it's not. What's 33 minus 5?
28.
So now what do I do?
Divided by 2.
Good. Divide both sides by 2. 28 divided by 2 is 14. So if x is 14, x plus 5 is 14 plus 5, which is 19. What do you think about 14 and 19? Go back to the original question. It works. 14 plus 19 is 33. Two numbers have a sum of 33, so they add up to 33, and one is 5 more than the other. Is 19 5 more than 33? Yeah. Is 19 5 more than 14? Yes. Do they add up to 33? They sure do. So those are the numbers. And so we finish with our therefore statement. Oh my goodness, my computer's going all over the place. Therefore, the two numbers are 14 and 19. And again, that's something that you might have just been able to kind of figure out on your own without the formal procedure, without defining let statements, but this is the requirement moving forward in math classes, and there is a reason for it. It's because as the questions get harder, these are strategies that actually help solve these questions. Okay? So that's a big part of the focus of what we're working on, is not just getting the right answer, but how we present the solution. Any questions? All right. Two numbers have a difference of 16. One number is 3 times the other number. Find the two numbers. So kind of similar. We're going to start with let x represent one number. If the other number is 3 times that, what expression do I write for it? Right? How do I show that a number is 3 times another number?
X times 3.
X times 3. So then, but there's a bit of a simpler way of writing it than I could write, like this would be a bit tricky, x times 3, because now I have 2 x's. So we don't usually write it like that. So how would I generally write it? 3x is the other number. And they have a difference of 16. How am I going to write that? How do I write the difference between two numbers? What does that mean? What operation is that? Subtraction. Which one's bigger? This is a little bit tricky, but for the most part, I'm not going to try to trick you or anything like that. So hopefully it'll be straightforward, but which one's bigger, x or 3x?
3x.
3x is bigger. So I'm going to do the bigger one minus the smaller one is 16. So you might have to kind of think about which one you're subtracting from the other. Now that we have our equation set up, we just solve. What is 3x minus x? 2x. Remember, this is a step that we're always kind of working towards, where I get something times the variable equals something. Divide by that coefficient. If x equals 8, 3x equals 3 times 8, which is 24. Therefore, the two numbers are 8 and 24. Is one of them 3 times the other? Do they have a difference of 16? Yeah. So we've got the right answer. Right? And the nice thing about these word problems is you can always go back and think about, does this answer actually make sense? What do you think? So small differences in the two questions, but generally the same kind of idea, right? All right, on the back you should find a couple more. These ones are a bit different. They're going to be quite similar in most ways. Actually, example 4 is different again, but example 3 is a shape type, okay? Which we haven't talked a lot about, but perimeter of a rectangle is 39 centimeters. The length is twice the width. Find the dimension of the rectangle. So we haven't done measurement yet. I'm going to draw a rectangle. I'm going to draw it with the length about twice the width. It does not have to be perfect. You do not have to measure it out. But, you know, close. If you draw your diagram way off scale, it's going to play mind tricks on you. Your brain is going to start to think, wait a minute, this doesn't make sense. But that might be just because you drew the diagram kind of wonky. So it is a good idea to draw it kind of in the way that the question says. Okay, so I've got width and I've got length. The length is twice the width. What does that mean?
The width is,
Well, yeah, I know it can be hard to say. It's half of it, yeah. It's double, so the length is double the width. This is like the last question. So our let statements, let W represent the width, then 2W is the length of the rectangle. Generally speaking, this might be a little bit of a teacher by teacher thing, but if you draw a diagram and label the diagram with the width and the length the way that we've done, you might not have to write your let statements. If you don't have a diagram, you have to do let statements. Sometimes a diagram is easier. I would recommend right now do both for practice, but some kinds of questions that you might see in later math courses, when you draw a diagram, that counts as your let statement because you've kind of defined your variables that way. Okay? But notice how they match. The length is twice the width. I've labeled that on my diagram. I've also defined my variables with let statements. Right? Now, the last part of this one is perimeter. What is perimeter? Again, this is not something that we've really talked about yet in this course, but you do it in grade 9, so you've seen it before. Perimeter is?
The length around.
Very good, the length around. What were you going to say, Lex? Same thing, length around. So all the way. In other words, add up the length of each side. So I've got W plus 2W plus W plus 2W, because this one is also W, right? Those are the same length. And this one is 2W, because these ones are the same length. And that equals 39, the perimeter. One W plus 2W is 3, plus another one is, plus 2 more is 6. Divide both sides by 6. Let me pull up the calculator because I think in this case the numbers are a little bit less friendly.
6.
Yeah, 6.5. We get a decimal. Find the dimensions. Okay, hold on. So if the width is 6.5, The length is
3.2.
no. It's twice the width.
Oh,
13.
Yeah, 13, good. But we can also just do 2 times 6.5, right? Or I could even write it as 2w, which is 2 times 6.5, which does work out to 13. So 2 times 6.5. And again, as we've talked about, you could imagine the numbers, if they were even less friendly, those ones aren't too bad. You might be able to do it in your head, but if you can't, use your calculator. Yeah.
What about the centimeters? Like
Yeah, so very good. What about units? Therefore, the dimensions are 6.5 centimeters by 13 centimeters. So you have to include them in your final therefore statement. If it's not the kind of question that has a therefore statement, that sometimes it happens, then you're right, you would just include them in the answer. Centimeters always include units for sure. What do you think? Notice how it's a little bit different because of drawing the diagram and that kind of thing, but similar to the first 2 questions, right? But we also had to understand how to calculate perimeter. Okay, last one. The sum of 3. This one's very different, but there's going to be a few in the practice that are going to be like this, so it's something that, practice it a few times and you'll get it. The sum of 3 consecutive numbers is 189. Find the numbers. I'm going to get us started here. Let x represent one number. No. Just one of the numbers. What does consecutive mean? Lucas.
Constant, I think.
Yep, good.
Like repeating.
Repeating, good. So if my first number is 8, what's the next consecutive number?
16.
That is a pattern that, and you could maybe do it that way, but this question means something a little bit different. Consecutive is 8, 9, 10. That would be 3 consecutive numbers counting. Are you counting by decimals? Are you counting by eighths? That part's not super clear, but you can just be confident that when you have a question like this, it means counting like whole numbers or integers. So you're counting by ones. So 8, 9, 10, 15, 16, 17. So 3 consecutive numbers, 3 numbers in a row that add up to 189. So if x is the first one, then what's the next one? This is where the sort of new part comes in.
190.
If 189 was the first one, but they add up to 189, it's not one of the numbers. Yep.
188.
Well, that would be the same thing, but that wouldn't add up to 189. What comes after x?
X2. 2x.
Close. X plus 1? Isn't that the next number? If the first number is 8, 8 plus 1 is 9. If the first number is 15, 15 plus 1 is 16. So x plus 1 is the next number. And what's the third? What do you think?
X plus 2.
Good. X plus 2. The sum of 3 numbers. Number 1, whatever it is, plus number 2, plus number 3 is 189. What's the first number? x. What's the second number? X plus 1. What's the third number? X plus 2. Good. Okay, so again, if I rewrite it without that other junk, it would look like that. I'm going to zoom in. And now I have an equation that I can solve. What if it was like 5 consecutive numbers or 10 consecutive numbers? And I'm not going to give you a question like that, but x, x plus 1, x plus 2, x plus 3, x plus 4, x plus 5, like you could go on and on and on. So it's the same kind of idea. Or 2 consecutive numbers. Or sometimes I've seen questions like 2 consecutive even numbers. So 6 and 8. So it'd be x and x plus 2. Or 2 consecutive odd numbers. So 7 and 9. Again, it would be x and x plus 2, because to get to the next odd number, you just add 2. But then the sum of all of them, add them all up, x plus x plus x, 3x. Good. I've got 3 x's. We're collecting like terms. Right now, this has nothing to do with the word problem. We're just solving. So collecting like terms on both sides. 1 plus 2 is 3. Now what do? Subtract 3 from both sides. And then divide by 3. So what does that mean? The first number is 62. The next one's going to be, and then, very good. So 3 consecutive numbers. Let's take a look. 62 plus 63 plus 64. 3 consecutive numbers. Well, look at that, 89. Right? So it worked. So again, you can check your answer by just thinking about it. So the 3 numbers are 62, 63, and 64. Once again, as I've been saying, when these questions get harder in other math classes, or maybe even later in this course, showing that step of actually calculating the other numbers, so the dimensions in this case, or up here, right? Finding out if one of the numbers is 8, the other number is 3 times 8 is 24. Showing that step is something that you're going to have to do. For me, when it's one of these consecutive questions, you don't have to show all that extra work. You can just say 62, 63, 64, that's fine. But again, some teachers are going to maybe ask you to show more steps or show your work entirely, and so you have to make sure that you understand what their expectations are. Okay? So we did 2 questions that were just the sum of 2 numbers that have a difference of 5 or whatever it was, right? And then a rectangle question, and then these consecutive number questions. Those are the sort of 3 different types that we looked at.